Right, so Apache Spark DataFrame API. All right, so I'm going to go through one by one, similar to what we did previously. So first step, we're going to do Spark shell command to do the example. So first thing, you need to open the terminal window. Let me just open the terminal window. So in Windows, that's going to be the command prompt. I'm going to run as the administrator, right? And then you need to type, let me change the directories. Data analytics, and then Spark test, and then enter Spark shell. Then it will start this Spark shell, right? And then in Mac users, you just need to follow the same kind of procedures. And then next, once it has started, then so since I'm capturing the videos and recording this, whatever it is trying to do, I'm doing, so that's why it's so much slower. So normally I tested it before, it was faster. So just text wire. Why text wire? Give me a second. Once it is loaded, then I need to go back to this hands-on activities, because in the slide I posted the source code. However, some of the source code you cannot easily copy from the PDF. So that's why I copied this actual source code here. Before running that, let me just go to the location, Big Data Analytics, Spark Test. Let me just get rid of this output folders. Okay. Right, just making sure the output folder doesn't exist. Right, we're good. Then let me just copy this code. Then, okay, Spark shell has loaded. Then I'm going to paste each line of code. What it is trying to do, it is simply trying to load the data from, whatever I have under the input folders. So input folder, you must have input folders. Inside, it should have some of the text box. So previously I created with this kind of dummy tags, right? So that's why. So as an outcome, so you will see this kind of results. So it looks like this, tabular shapes, right? So because DataFrame is utilizing similar kind of, the Python, pandas DataFrame. So that's why it shows a similar tabular shape of data representations. And the last part, it is trying to save creating the output folders. When you go back to the folders, you will see this output folders also generated. Then, so only the different part is going to be it generates CSV files. Previously, it was generating some kind of unknown kind of text formats or the files, but it's generating CSV file because DataFrame it's utilizing the tabular shapes, so that's why it is able to generate CSV file much easier ways. Okay, once you finish this part, then you can let me just go back to the slide. Yeah, once you finish this, then you can just screen capture that. Okay. So when you are having some kind of issues, so I added some kind of possible error messages you probably can see. So you can just follow this step to handle those kind of possible cause of a problem. But in most cases, you will not see this kind of problems at all. The next step is going to be using Jupyter Notebook. So it's the same thing, Spark Scholar, so the DataFrame, but instead of using Spark Shell, it is going to use the Jupyter Notebooks. So let me just try to open the Jupyter Notebook. I'm going to load the Anaconda here. So while it's loading, let's try to move on to the next slide, right? Once you open this Jupyter Notebook, so then you have to launch Jupyter Notebook page with the what? Scholar. So simply using Apache Tori. So this means you have to finish the previous activity, hands-on activities for doing this. Otherwise, if you have not completed these previous hands-on activities, then you cannot accomplish these assignments, right? So loading the Anaconda takes a while because I'm loading so many modules at once. Okay, launched. Let me just open this Jupyter Notebook. All right, so it started. All right, so I need to launch Jupyter Notebooks with Chrome language as Scholar, Apache Tori, right? Once I open that, just go back to the slide. Then you need to copy this. So this, you can run line by line, or you can just copy everything at once. So if I do, so here, go back to the blackboards. If you're just adding line by line, you can do that as well, right? So it is running good, right? So if it is first time, it's trying to bind Apache Notebook to the Scholar. So that's why it takes some time. And then second part, so I'm trying to load the data sets. Right? So, and then, so if you just enter this text bar, it's just show this RDD directories. It is not fetching or any of the contents from the files. That's because we talked about that's because it is support the lazy evaluations. It only does when we need to get the data sets. So here, trying to convert the text file to each of the lines. So as a data frame, and then let me just load everything up until here. So this show that is going to be the moments how this whole data set are going to be loaded and then processed. Because the data frame does not provide compile time, the data error, syntax error checking. So that's why it's not doing anything. So only unless it sees it runs some of the data computations. So there is no errors. So that's why it shows those kind of corrected results, right? And then also the last part you need to do is simply save those results into a file, right? Then you will see the second output folder is generated, right? So same things. You can see this CSV file also created as well, right? So once you finish that, then you also can do for the second part as a screenshot, generate the screenshot, and then submit, right? Then third one is the PySpark at interactive mode. So instead of Spark Shell, we are using PySpark in a command prompt. Let's go back. Doesn't work. Just terminate it. Sometimes it doesn't work. So PySpark is supporting the Python program language, right? same thing. So you are doing the same data frame, some of the syntaxes. However, this time, instead of using Scala from language syntaxes, it is using Python, right? Because internally, Spark also provides some kind of, the interpreter, right? Conversion, when you're entering the Python code, it's going to be converted to Scala syntaxes. So let me just copy this syntaxes from online website. So the next one is this one. You also can do the same ways, copying everything, then paste it, trying to load the data, and run it, right? And they generate another files, right? So another folders. So you can also check it up, this word count df data frame. So if you just trying to show df.show, then you will see what kind of contents appear inside, right? So once after you finish, then you also can do the screenshot as well, right? The next part, going back to the Jupyter Notebook, but this time you need to use Python instead of Apache Torah Scholar from language. Going back, so instead of using this, so we finished this. Let me just close that. Then this time you need to open this Python notebook. Inside of Python notebooks, you need to run this code. Then run it. One thing you have to making sure is when you're using PySpark in command prompt, so here, we never enter any initializations. When you're using Spark, you need to have initialization. However, in Jupyter Notebook, Python Jupyter Notebook, you need to enter these two lines of code. Otherwise, it is not trying to bind your Python programming Jupyter Notebook with Scala, right? Simply not Scala, so Apache Spark. So these two line of code is trying to connect those binding operation between the Python and then Apache Spark, okay? Right? Then I try to add additional explanation here. So let me explain. So first part here, Spark sessions. Whenever you are trying to do the Apache Spark programming, you're always required to creating Spark sessions. That Spark session, when you go back to this command prompt, when you are trying to load Spark Shell or the PySpark, it automatically load this. So as you can see here, the message Spark context available as SC, it automatically Spark context, it automatically loaded for you. However, if you're using Jupyter Notebook, you need to create this Spark context first yourself. That's why here, this line of code is going to be necessary, right? And then also later, I'm going to cover some additional kind of exercises for you that also utilizing this kind of beginning portion. So every time when you're using the Python with the Spark programming, these three line of code are going to be the main portions. I'm going to repeat that again next time, right? And then once after, we're going to do the read data, right? All the data text files from these directories. And then here, so we saw the Hadoop. When you're using the Hadoop, we often look over the mapper and reducer mechanisms. So here as well, it is trying to do the selections, and they're also trying to do some kind of mapping operations. So simply from this original data set, this is the original data set. It generates all the words, collection of all the possible words, and then changing into individual line of words. So this Second part is going to be, we are saying that records generation. And then third part is generating word by word generations. And based on this command, we can count how many words appears in the text, right? And this is another example. So when we are loading, all the data exists in the data text files are loaded as a record first. And when you're trying to do the word counting, then from this word record, we need to parse each individual word by word. Then we can do the word counting. So that's going to be the necessary portions. We saw that here, a line of code. Okay. Then if you want to, we can do, save it as CSV format. So that's pretty nice features what the DataFrame supports. So however, when you are using the RDD does not support generation, direct generation of CSV files. We need to convert it to DataFrame and then save it. Right? And once you finish anyway, so you can capture this as the fourth part. The next part, next two parts, you're generating simply the jar files. So jar files, we talked about when you learn the Hadoop file systems, jar files need to be created when you're submitting directly to the additional servers. So when you're trying to run multiple servers, then this Spark submit method is going to be the one you should try. So simply all the previous steps when you're trying to do the programming yourself, all the previous steps you need to follow. When you're trying to utilize the existing cloud servers or any kind of server systems, then you have to utilize this Spark Submit. And then as a first step, so here I also create this Spark word count the source code for you. So normally you have to create yourself like this Spark word count, but since we do not have much time, so I create the source code. And then you just need to save this. Let me just copy this from the web page. So I already posted this source code. So here is the source code. Then we need to generate and save it as a Scala files. So let me try to create the folders for this. All right. So here I'm trying to create the folders for the Spark RF and then creating some text file. Save the contents. Then I need to save this as Scholar df cluster word count the Scholar. Okay. Once you do that, then you have to also create this build.sbt because for generating jar files, we need to use SBT. Otherwise, we cannot easily create the jar files. Also, for this command, this contents as a part of build.sbt, I also uploaded there on the Blackboard, so you can just copy that. So if you're using different Scala versions and the different Spark versions, then you have to making sure the version number properly added into the SBT file. Right? So here I need to create build.sbt and then adding contents, right? Then what's next? And the next step, you need to format. So when you're using the SBT, you need to organize your tree structures looks like this, right? First, so let me just open that. You need to create, just reference by adding these two, by showing these two applications together. So first, the root folder, you need to add this build.sbt. Then underneath, you need to create src. Right? Takes a while. What's going on? Somewhat slow because I'm running so many applications. this time. Right? Let me just copy this because we have to place it under the scholar. Going into SRC, create main. Yeah, so much slow. Why? Because I'm doing the video capturing. So while I'm doing the video capturing, that WebEx video capturing is saving into my local hard drive. That's why it has some kind of lag happening when I'm creating these folders. Okay, but your case is going to be much faster, right? So you're not saving anything. Come on.
Did you change it to your local hard drive? I think so.
Yeah, so if it is internet, network saving, then sometimes the network content connection is not stable. So I noticed that, when I change the network storage setup, cloud saving options, when I lost connections, everything got disappeared. All right, so once you have this structure, SRC main, Scholar, and then adding this source code of the Scholar, then let me just go up to these folders. So what you need to do, you need to run build command. So here, this is a command, sbt package. So what you need to do, you have to go back to terminal window, just quit that. Then you need to move the directory to here. So that's under the Spark df, right? So here you see the build.sbt. In here, you need to enter the sbt package, right? This command. Then automatically it is trying to start generating the jar file. Of course, it's going to be faster normally, but as I mentioned, I'm doing the video capturing, saving into my local hard drive, so that's why it's so much slower. So since our program is not that complicated, it probably takes a couple of seconds. So it's doing the compilations and then trying to check all the necessary class files and everything. So, okay, boom. So once it's done, it generates this additional files. The project, we never create the project folders. Targets is also generated. Once it properly compiled, then you will see the jar file exists under this target folders. So under this target. So if you go to targets, you will see, and then here the scholar, then you will see this jar file exists, right? If you do not have this jar file exist there, then probably you didn't follow some of the steps. Then once you do that, then you have to run this. As you can see here, we are using local computer machines. So if you are just changing this to any of the Spark servers or the Hadoop servers, then you can utilize another additional server machines for running this. So that command I also added here in Blackboards. So I just need to copy and go back. Oh, sorry. Copy it properly. Right? And then right. Okay. So it runs good, right? So there will be no errors happens. Of course, I tested before. So once you finish, then let me just go back. Then you need to generate this log files. These log files. Of course, there will be no errors happens. Of course, at the end it has some kind of deleting errors, but you can just ignore that. So it's just a temporary error message. So I double check it out. But when I go back to the output folders, I noticed that output folders correctly created. And if I open that, then there is a proper result, right? So what you need to do, simply you just need to delete this once again for generating log file. What you need to do, you just need to add this line, right?
Oh, so you have to make a log file?
Hmm?
You have to make a log.
Yes, because the log file you are going to submit. So this case, so 5 and 6, the follow up, you just need to create the log or generate the log file instead of screen capture. Okay. So you just need to go back once again and adding this arrow, the bigger, the smaller symbols, and then adding this log file names, color, df, cluster, word, count, the log. Then all the activities you saw here are going to be saved into this log bars, right? Then you can submit this log file as for these steps, okay? So it takes some time because my computer is getting slower. And the last step is going to be the same thing, Spark submit, but this time you're using PySpark, not this color. So the code slightly different, right? So this or the source code also appears here. I nicely copied here and shared. So as you can see here, it is utilizing Python code. So this Python code versus Scala code is completely different. Scala is quite similar to Java programming language. The Python is completely different, right? So this is the Python. The Python code, you just need to copy that as well. So you need to save it into this kind of file names. Let me do that by going maybe here. I'm going to create here PySpark, df, cluster, word count, py, then open up, then copy Java code, the Python code, save it. Then next slide, you just need to submit. So this case, as we know already, Python, you do not need to compile. So that's why it is not using SVT. It's not generating any of the Java files. We directly submitting this Python code using the same Spark submit, right? So let me just try to show how it runs. So if you just copy, go back to command. So the previous one, as you can see, there is a log file generated, right? So I create the Python code here, right? So I'm going to run this command in here. So for this case, we just run, then it's the same things. So you receive a bunch of messages popping up, but it's utilizing simply the PySpark command. And then once you finish, then you will see this kind of, you will see the, oops, go back. You will see this output folders are generated, right? That's it. Wait a second. Something error message happens. Spark warehouse path does not exist. Oh, sorry about that. So I made a mistake on the defining the input folder. So my input folder path is not this, right? So that's why it caused an error. So let me just go back to the file here, Python code. Not this. Sorry about that. Yeah, so not this. This. Wait a second. Yeah, let me try to change these locations above. Just trying to make it easy to run, right? So PySpark going above here because I'm trying to access input folders and then generate output folder in the same locations, right? So that's why. So here, right? There is the input folders here, right? And then output folder I can generate. So here, input folders, and then output folders I can generate. Right? It runs good. So then you see here the output folder generated, right? Same things. Once your program runs good, then you can also, let me just change this. You can also create the log files. So going back here, yeah, by adding this, right? Oops. By adding this with this symbol, okay? So let me just add. Then the log files you can generate by Spark3 cluster or count.log. Then it will generate the log files. Where is that? Yeah, in here. Yeah, it finished. Then you will see the log file. Oh, not these directories. The same location where your source code is. Yeah, here. You will see these log files. If you open that, then you will see a bunch of the log messages, what has happening, right? So everything runs good, right? Then you can submit that as a part of it as well. Okay, so once you follow these whole the steps, that's going to be a part of this assignment 10. Okay.
Sometimes Blackboard won't allow you to update files of a certain.
You do not allow what?
Not long. I don't know if Blackboard would let us upload that.
You can give everything. So as you can see here in the instruction file, he asks you to zip every file, including the screenshot and logo. Right? Any questions? That's still assignment 10, right? If you want, I can generate more assignments, but since we are running out of time, so that's going to be the last assignments I can expect. So you need to submit on time. Try to. So this due date, I set it up as April 29th, especially graduating seniors must submit it by the end of, almost the end of this month, because I need to post your final grade. If you're not graduating seniors, maybe you can delay 1 or 2 days, right? Or maybe if you're late, maybe 1 week, then maybe there will be some deduction, right? But our final exam, as I mentioned, is going to be, oops, this. Final exam is going to be, for these three graduating seniors, is going to be Monday, April 20, Wednesday, April 26th. So So if you're graduating seniors, you do not need to come to class on 24. So this whole week is going to be your exam week, right? So you need to spend your time studying and then taking the exam. Others, the exam is going to be May 8th. That's going to be the official dates defined by the university. Okay, we're going to have the exam on that date, right? Try to submit the assignments, right? Everything's right before the your final grade posted. Once your final grade posted, there will be no going back, right? University recasting the instructors to submit why this person's grade need to be changed, right? Those kind of statements they're recasting. So that's why it's not justifiable, right? So once you grade posted, then there's no going back, right? So you have to making sure submit your assignments, right? Before your final grade posted, right? Then also once your into almost final grade is going to be ready, then I'm going to share through the Blackboard. Okay. I'm going to send the notification by email, so you better check it out. And then the exam is going to be based on these materials, right? So practice questions, I also added answer sheet, right? And then also plus previous exam questions, okay? Previous exam questions, and then these are going to be a part of your final exam, right? If you're not graduating, of course, the next week, Monday is a holiday. You can enjoy yourself. Then Wednesday, we will have a class, right? What we are going to talk about on Wednesday. I have bunch of actually. For the Spark, I have bunch of practice guide, but I'm probably going to talk about some of the exercises, DataFrame in Jupyter Notebook with some of the additional features, like how you can do similar to the pandas, right? Data fetching. You can see the printing, the schematic design, and then how you can fetch specific columns, right? That I'm going to show. And then also, if time permitted, then I'm going to explain a little bit of this one, Databricks. Have you heard Databricks? Yeah, probably not. Databricks is a website, the company website. Once after people finish up creating the Apache Spark, they actually utilize Apache Spark as a business consideration. And then they built the company named Databricks. That company is provide Apache Spark through the online website. So if you have money, yeah, you can buy some kind of services because they provide online server capability through the Amazon, EC2, right? Also nicely, they provide some kind of community editions. So this, I'm going to explain how you can generate the community editions and then how you can create some of the simple Apache Spark data frame activities using Python, then how you can do those kind of activities directly on there, right? I'm going to explain, right? Then also, so if you're not graduating seniors, then you should come to class continuously, right? On Monday, 24 as well, right? And then also you should come 26. Some of the graduating seniors probably they're going to take the exam, maybe sitting around here, but we're going to continue the lecture, right? So 26 probably I'm going to show you some additional activities. Like this. So supervised learning and then unsupervised learning with Python and PySpark how we can do. So I'm going to show in So I'm not asking you to do some kind of assignment, but I'm trying to show you some of the additional possibility what you can do within there. Maybe later once you